Okay, let's share screen on the window. All right, so let's continue. Once again, slope, y-intercept formerly being called initial value. Since we are now dealing with 4 quadrants, that's not the initial value anymore. The line continues on. That's why we have to give it a new word, a new name. So given this, same thing, you are always looking for a y on the left side and whatever else on the right side, which will allow you to find your m and your b. My m is 3 over 4. So rise of 3, run of 4. In this case, a rise of 5 and a run of 1. And my y-intercept is an x value of 0 with a y value of positive 2. Slope, negative 1 over 3, which is a rise of negative 1, so 1 down, 3 to the right, or it's 1 over negative 3. They're both correct. We have a y-intercept of x equals 0, and y is negative 3. I hope that's pretty straightforward. With all of the practice we've done so far, that stuff looks familiar to you. Okay. Any questions so far? Yep. Pardon me? Of course. Here's my argument. Ready? If my x is a 0, what is 5 times a 0? 0. Plus 7. 7. So when my x equals a 0, my y value turned into 7. Oh, sorry. Oops. Minus 7. So I have negative 7. When my x was a 0, y became negative 7. Try again. Look here. Y is equal to negative 3 over 4 times a 0. What is that? 0. Plus 2. 2. When my x equals 0, my y value is a 2. It's always going to be like that. X value is always. There. Okay, practice. We'll do one more together. Slope is a negative 3 over 1. Or, of course, 3 over negative 1, they're all the same. The y-intercept is 0, comma, negative 2. Okay? But if you could do it this way, you should be able to do it in reverse as well. Looking at the next page, I'm going to give you the slope and y-intercept. You should be able to pull out an equation instantly. So let's do it. Determine the equation of a line with the following properties. Slope of 3, in other words, m equals 3, y-intercept of 6, which means b equals 6. Remember, y-intercept is 0, 6, and so the b value is 6. My equation immediately is y equals mx plus b of 6. That's it. You might be thinking, what do we do with the x and y? If you're giving me an equation, the x and y has to be a variable. It has to be unspecific. So that if you want to know when x equals 1, you can calculate it. If you want to know when x equals 2, you can calculate it. Next one. Slope is 1 over 2. Rise of 1, run of 2. And the y-intercept being 0, comma, negative 5, my b value is a negative 5. That means y equals m x plus negative 5. And do I want to write plus a negative 5? That's redundant. If you have a question like this, please just rewrite it as negative 5 or minus 5. Lastly, slope is negative 3 over 5 or 3 over negative 5, whichever. And a y-intercept of negative 1 over 4 means the point is 0, comma, negative 1 over 4. And my b value that I plug in is a negative 1 over 4. My equation, y equals m x plus b, which is minus 1 over 4. Let's keep moving. If I give you an equation, you should be able to pull out slope and y-intercept. If I give you slope and y-intercept, you should be able to pull out an equation. Both of these should help you with a graph and vice versa. If I give you a graph, you should be able to pull out the y-intercept, the slope, and then give me an equation. Just as if I give you an equation, you should be able to graph. Here we go. What is my y-intercept? Going once, going twice. Good morning, Taylor. It's right there. That is a 0.03. You okay? Which means the y-intercept is 3. Right there. Next, calculate the slope. Which one do you want to do? C to D? Since the points are given to you, how about we do that? Slope is equal to the change in y over the change in x, which is the same as see. 1 is the y value, 4 is the x value, minus minus. 5 is the y value, and negative 4 is the x value. 1 minus 5 is negative 4. 4 minus negative 4, that's a 4 plus 4, that's an 8. My slope is negative 1 over 2. You found your m, you found your b. There's your equation. It's not supposed to be rocket science, but you need to be able to navigate in any direction you need to serve a purpose. Now, what's this math good for? Well, there's a lot of applications that will ask you to talk about a relationship, particularly in science and business and whatever. If you've ever dabbled with numbers in real life, you will see that you're always trying to compare two different things, and that's a graph. You need to be able to work through a graph mathematically for it to be useful in any given situation. Okay. Any useful situations in life. Here we go. Same thing here. My b is going to be right there. So that's going to be a 2. My slope is going to be, let's see, my y value is a 0. My x value is a negative 2. Minus, minus. My y value is a 4. My x value is a positive 2. 0 minus 4 is a minus 4. But negative 2 minus a 2 is a minus 4. My slope is a 1. Therefore, the equation is mx plus b. Please use that as a template for the third example, because I like to get through more of these. Graphing linear relations in slope y-intercept form. If I give you the equation, just like how a graph gives you an equation, if I give you an equation, you should be able to graph. Here we go. Here is your equation, 1 over 3 x plus 2. Start with the y-intercept, which is 0, 2. Please place that there. That's the first step. Second step, look at the slope and draw in more points. What do I mean? What does 1 over 3 mean? Please, somebody from yesterday or 2 days ago, you gotta remember. What does the 1 tell you and what does the 3 tell you for a slope? Yes, this is a rise, right? And since that is positive 1, it means 1 up. That means, somebody else?
30 to the side.
To the side. We're going to call that a run. That is a positive 3. That means it's 3 to the right. Okay, so not just side, be a little bit more specific. From my y-intercept, I'm going to move up by 1, 3 to the right. Up by 1, 3 to the right. And up by 1, I ran out of space. The left side is empty. If this is true, I can also call it, right? From a location, I went up by 1 and 3 to the right. So I'm going to do reverse. 3 to the left, down by 1. 3 to the left, down by 1. If I go up and right, I should be able to go down and left. And in doing so, I have with me a graph. Safe to say, for the future quiz and or test that we're going to have for graphing, you might want to bring a ruler. If you don't have one, I will try to have a couple. Like right now, I have this triangle thing up here. I have a box, but they're not very ruler-like, so I highly recommend you find something. Okay. Remember to add arrows on either end. I will. There. Another way to do it is after you draw the arrow, I want you to label it and say this is equal to y equals 3x plus 2. It's always nice to label. Okay. On the same grid, graph the following. I am going to leave this with you as a practice, and I'll fill it in. But please remember, the slope of -2 is the same as -2 over 1. What does that mean? Yep. Correct. Or? Yes. Up to left 1. Please do that on your own time, and there's more practice here for you. I think this is our last real exercise, and that is the concept of horizontal versus vertical lines. What would you say is the slope for a horizontal line? Am I going uphill or downhill for a flat surface? We're not going uphill or downhill, so the slope is a 0. So if 0 is reserved for horizontal, what do I call vertical again? What is the slope of a cliff? Infinity. That's why for horizontal, we have a slope of 0. For a vertical, we have a slope that is unnumberable. It's not definable. You can't give it a definition. It's not even a 0. A 0 is a number. Okay? So how do you represent something that's horizontal? Well, think about it. If m equals 0, y equals 0x plus b. What's anything multiplied by a 0? 0. That's why the equation is just y equals b. For a vertical line, it's a little bit different. Consider this thing right here. Why does it make sense to say x equals some number? Everyone, you with me? Just stop writing and take a look at here. What is this point? And what is this point? What is that point? What is that point? And what is that point? What's that? Huh? Not the y. What's this point right here? 5, 0. What's that point? 5, 1. What's that point? 5, 2. This is 5, 3. That is 5, 4. That is 5, 5. And it keeps on going. What keeps on going? This keeps on going right here. What is common with all of these points? X equals 5. So here, that line right there, that's why we call this line an x equals 5 line. Because y could be anything, but x equals 5. So we just talk about the x. Here, we just talk about how y equals a number. Okay, let's practice. See if you can match it with a vertical or horizontal. Graph the following lines in the same grid. Be sure to label each graph. Let's talk about this one just because we just said it. X equals 4 at all times. X equals 4. X equals a 4. X equals a 4. X equals a 4. X equals a 4. No matter where I draw, X has to equal a 4. I think you would agree that the only line I could draw with that detail is this vertical line, and we say X equals 4. So what about y equals 2? Y equals, negative 2. Y equals negative 2. Y equals a negative 2. Y equals a negative 2. No matter what, y equals a negative 2 because the slope is 0. Okay? So I threw a lot at you, but all of it deals with the equation y equals mx plus b. We have practiced y equals mx plus b. We've practiced calculating slope. We've practiced looking for the y-intercept. I hope that you will give this worksheet a chance before you leave today. How about you give yourself an honest attempt up to 11 o'clock, which is about 20 minutes. And then we'll start thinking about doing some other things. As I said before, if you take a look at our previous lesson, I gave you a handout. Oh, no, I gave you a handout with a exercise, right? Let me see if I could go back to sharing the entire screen. Right? I gave you an entire exercise sheet from 5.1 where you really test your mettle on slope. If you find this to be challenging, I have a feeling you will make lots of unnecessary mistakes for 5.2. So please make sure you can do 5.1 and 5.2 over the weekend. And then also remember to have some fun. Questions? All right. What are my expectation for the next 20 minutes before 11 o'clock rolls around? Please give this package an honest effort. Okay? Let's do it.